Good day, class. In this video, we will continue how to derive position vectors. And for now, we will start it in a Cartesian manipulator. Okay, so just remember, class, if we are deriving position vectors, we are just getting the distance between two origins of two frames. So we will get the position vector from the frame 0 to frame 1, or P01, or the position vector of frame 1 reference or relative to frame 0. Okay, so let's go to the base. Then from frame 0, so the distance between the origin of frame 1 and frame 0 along x sub 0 axis. Okay, along x sub 0 axis, because frame 0 is the reference frame, is 0. So why 0? Because along x sub 0 axis, there is no assigned link length. Okay? There is no assigned link length. The assigned link length is at the z sub 0 axis. Okay? A sub 3 link length is assigned at z sub 2 axis, not at x sub 0 axis. So, the x coordinate here is 0, or the x element is 0. Okay, as well as the y element, because at y0 there is no link length along its axis that will describe the distance of these two origins. Okay, so this is also 0. So along z sub 0 axis, there is a link length a sub 1. Okay, there is a link length a sub 1. So we will write here a sub 1. So a sub 1 is the distance between these two origins. Okay, between these two origins, the origin of frame 1 and origin of frame 0 along z sub 0 axis. Okay, so this is the position vector from frame 0 to frame 1, or the position vector of frame 1 relative or reference to frame 0. Okay, next. So we will go to frame 1 and frame 2. So the distance between the origin of frame 1 and frame 2. So the reference frame is frame 1. Okay. Along x sub 1 axis, there is no link length, so this is also 0. Along y sub 1 axis, there is no link length, so this is 0. Okay. Along z sub 1 axis, we have a sub 2 plus d sub 1. Okay. A plus 2 plus d sub 1 is the z element. This is because a sub 2 is at the axis of z sub 1. And also the frame 1, this frame 1 is a prismatic joint, and prismatic joint has joint variable d. Okay, because this is a joint variable, we will add it to the link length. Okay, so this is a2 plus d1. Next, from frame 2 to frame 3, the reference is frame 2, the projected is frame 3. Okay, so the distance between these two origins are 0 at x sub 2, because there is no link length along x sub 2. Also 0 at y sub 2, because there is no link length at y sub 2 that describe the origin from frame 2 up to the origin of frame 3. Y sub 2 is at the axis, is at the distance or along the axis of Z sub 1, where the origin of frame 1 or between the origin of frame 1 and frame 2. Okay? But it is not at the axis of the distance of the origin of frame 2 to frame 3. So this is also 0. Okay? So along Z sub 2 axis, we have A sub 3. And because frame 2, this is frame 2. Okay? Because frame 2 is a prismatic joint, it has a joint variable D. So we will add the joint variable. So A3 plus D2. Okay? So this is the position vector of frame 3 relative to frame 2, or P23. Okay? Next. So we are at P34, or the position vector of frame 4 relative to frame 3. So that is the right way of reading this. Okay, the right way of reading this is the position vector of frame 3 relative or reference to frame 2. But you can also call this P23, P34, P12, or P01. Okay. Or the position vector from frame 0 to frame 1, or position vector from frame 1 to frame 2, or position vector from frame 2 to frame 3, or position vector from frame 3 to frame 4. Okay, so we are at the position vector of frame 3 to frame 4, or the position vector of frame 4 relative or reference to frame 3, or P34. So the distance along X sub 3 axis is 0. Along Y sub 3 axis is also 0. But along Z sub 3 axis, it is A sub 4 plus, okay, plus the joint variable D3, because the frame 3 is a prismatic joint. Okay, remember that. Okay, so A4 plus D3. Okay, so this is the position vectors of a Cartesian manipulator.